Well, good morning, everybody. So we have Pulkit Jaiswal with us from Swomax, bright young lad from Singapore. And his company basically took the relatively old idea of autonomous drone pods and added a spin to it with AI. Then we have a slightly less young but no less bright AirMap engineer and AirMap CTO, which is a long history of robotics, mobile devices, autonomous cars. Was the CTO of HERE and Symbian Foundation, and led the development for Motorola Droid and brought Android to Nokia. So it's in the industries, a lot of tech industries left and right. Jumping right in with the panel title, are we still excited about the drone market? What's your take on that?
You want to go first?
Well, I feel like working in the drone industry is kind of like dating. You know, you fall in love with drones, you're obsessed with it, and then over a period of time you realize some things work, some things don't, some things make you really happy. And then you eventually get a worldly perspective of things, and you focus on the right things. So I feel like the last 4 or 5 years in the drone industry, having been working on different companies, we've learned a lot. And we've actually figured out things that will generate revenue, things that will create value for customers. And we have scrapped away things that do not do any justice to anybody in the industry. So I guess that's where I stand. We are still very excited and in love with drones.
Excellent. Daniel?
Yeah, so I think I told you before that I built a drone about 20 years ago. It was a sailing drone, but it was fully automated. And I thought that there's no use for this right now, so I better go find a way to make a living. And I did mobile phones, I did autonomous cars, geospatial, and all of these technologies converge really well right now to the very exciting world of drones. I've been part of this for the last 10 months, I would say, and I'm pretty happy with the change of my career. So it's extremely exciting, and I think it's getting excited every day as new developments on the regulatory environment, on the technology front, start to converge, to open up and to see many more flights up in the air, which we don't see today, but we will see in the future. So yes, absolutely excited about it.
Excellent. Since you have a pretty long experience in the mobile industry, if we had to draw parallels with it, at what stage do you think we are in the development of the drone industry?
So my perspective is from the penetration in terms of the number of flights and the regulatory environment. We're actually pre-GSM. So I would say that that was I'd say we are in the 1985, 1990 time, right? So still a long way to go, but a lot of excitement is going to get us there.
So we didn't see anything yet, basically, that's your
I think we haven't seen the potential that these has, right? Absolutely not. And I gauge that also by when I tell people that I joined the drone industry, I have to explain a lot. And, from folks that are actually in the industry, folks that are actually outside, but in general, I think that there's not a lot of understanding of, what can be done. Folks like, Swomax, they know it really well. They've been at it for quite a while. They know the potential. But outside of, the industrial enterprise phase, what you see is, the nuisance, perceived nuisance of, people taking pictures with drones, which I think is a great potential, and it will develop further, but it's not exactly where the industry can go.
And not a huge moneymaker for the industry as a whole, as of now, I guess. And not a huge moneymaker for the industry as a whole.
Exactly, exactly.
Do you subscribe to that vision, okay?
Well, so since we take care of drone automation, I would like to compare where we are with self-driving cars. So I think where we are, what Swarmix is doing, or what the state of the current drone automation industry is where self-driving cars were back in, I would say, mid-2012. Cars had, covered a certain number of miles without any accidents, and they were, generating value. In our case as well, we have, thousands of hours of flight time done fully autonomously with customers. But again, only after we collect a certain number of hours, we can go out and, publish so-called white papers with customers and show the world that autonomy makes more sense than having a human pilot fly a drone and, deliver the same data. Faster, cheaper, and more efficient. So I think only after we collect a certain amount of hours, the entire industry will move forward. And obviously having other competitors in the space doing the same thing will help us as well, because it will generally drive the industry forward towards full automation. So I would give it about another 2 to 3 years before services are completely obsolete and we are moving towards 100% automation.
Okay. And if you had to say, what do you think is going to be the biggest moneymaker or the most profitable industry for drones as sensors or drones as delivery tools, or whichever other take on
So for us, the answer to this question has been the same for the last 4 years. For us, it's infrastructure management. And I'm talking about extremely expensive critical infrastructure owned by big billion-dollar companies that are placed in extremely remote areas that need to be managed. By manage, not just in terms of inspecting the infrastructure for defects, or finding faults in it, but also securing the infrastructure, making sure that nobody is intruding and vandalizing the property. So infrastructure management would be my answer.
I was attracted to the same thinking. First of all, in terms of the level of automation, I think that where the technology is pretty accurate. And when we think about a future of how can drones influence society, is going to have to go through fully autonomous, not independent flights. And what I mean by that is that there will always have to be some form of human supervision about all of these flights, and the ability to take over a flight in case of hazardous conditions. But it's going to be fully automated, and we need to remove the pilot from the picture. The notion that we have today of a drone, flying tethered to an RC
guy
set,
with a remote control. Yeah.
That is not exactly where the industry is going to go in terms of increasing dramatically 10x, 100x the number of flights per day. Mm-hmm. And I would also subscribe to the thought of delivery. It's an interesting thing, but it has a lot of complexities built into it, because actually it's a machine to a human interaction somehow, or machine to a deployed infrastructure to do the deliveries and so on. Whereas inspections actually can benefit society greatly, and it doesn't have that added complexity of the interaction at the target point.
Right. And speaking of missing infrastructure, what do you think needs to happen, or what are the technology pain points as of today?
Well, I see flights taking place in cities, and cities are actually very complex environments for the operation of a drone, right? So GPS, which is one of the traditional positioning methods, will not work because of urban canyons and so on. It's
walking between skyscrapers in Hong Kong with Google Maps teaches us.
Correct. So I think that gives you an idea if you want to do a package delivery, where are you going to deliver it to? And but we firmly believe that is the future. We're working towards that, and we want to help all of the companies in the space to achieve those goals, including transport of human beings in urban environments as well.
Yeah, that's a vision that doesn't a product that doesn't often gets talked about when we talk about drones, but it's certainly going to be a huge one in the industry, I think. And how about you? What do you see as a missing
I think
technology in the stack?
I think Daniel pretty much summed it up. In our automation space, we call it precision landing.
Yeah.
How do you precisely position a drone or a landing pod, make it exactly land inside it? We were living in 2017.
What you guys do, right?
Yes, we were living in 2017, and GPS still has about 1.5 to 2 meter accurate, error radius. And in order to make our system work, the maximum error radius we can afford is 20 centimeters. So we have to make a drone land exactly within that space. That's a huge problem. Even the military has solved it to some extent, but it's very expensive. And I would say the second thing is a lot of sensors that customers want to use to inspect their infrastructure, they need to be miniaturized so they can be put on the drone. And the miniaturization process, not a lot of companies or startups are willing to afford the 8-figure investment risk of making it happen. So the owners of these sensors are basically a few companies, and the prices are still jacked up. So for an industry-wide adoption of these sensors, some people have to come up with their own sensors
and develop cheap ones.
Yes.
Well, after all, the whole consumer drone industry was made possible by the mobile industry.
That's right.
Which miniaturized and made cheap GPS sensors, cameras, and.
But that was
achieved
through volume, right? So
yes.
That's the key thing.
Economies of scale.
That industry was driven primarily because it was a huge market. and the volume was, when I was at Nokia, we were manufacturing 1 million, phones a day.
So cheap batteries, cheap cameras.
I'd love to get to the position
sensors.
where we manufacture 1 million drones a day,
Yeah.
right? So,
And probably more for you, Pulkit, have you perceived a loss of an increase of interest by investors when you fundraise for your company?
So, I mean, hardware is always hard. So, honestly, we would have never gotten into the hardware game if somebody else was building a platform that works reliably. The thing is, some company has to go in and fully automate end-to-end every operational aspect of flying a drone over an infrastructure. Unfortunately, when we started the company, nobody really had a solution. So we had to try to come up with this so-called gold standard platform and set the stage for creating an industry-wide architecture. But moving forward, I think our attention is moving drastically towards data as opposed to hardware. The hardware has already reached a point where we can launch a drone, retrieve it reliably, recharge it, and send it again in about 20 to 30 minutes. On the software side of things, however, there are extremely amazing opportunities out there, especially related to how we can take our AI libraries that we've built that allow the drone to perceive different kinds of defects in infrastructures and apply it across a whole spectrum of other companies, and also in the robotic space. Not necessarily drones. They could be ground robots. They could be underwater robots. They could be police cameras looking for certain things. And we are able to spot and detect, analyze, and spit out the actionable insight. And that part of the business is actually taking off really well as well. So I would say things are still looking really good.
Good, excellent. And on the airspace and regulatory side of the things, how do you see the perception shifting from the point of view of authorities? Do they perceive more risk, less risk? They welcoming automation, or they want the human in the loop?
I think there's a lot of positive work happening in that space. The first conference that I attended when I joined ERMAP was the Drone Challenge, and that was pretty upsetting in the sense that it's more of a drone opportunity, and of course we have to bring together traditional aviation, which is heavily regulated, into what drones are today. If you have a skateboard that hovers at 1 meter above the sidewalk, is that subject to FAA or
legally? It's an airplane.
Exactly. So I think that there's an in between, and the way to achieve that is through a lot of commitment to the technology, a lot of commitment to developing those standards, while at the same time not forgetting that they need to fit into a bigger picture that involves traffic management, that integrates with beyond Class G airspace and these kind of things. So there's a lot of work happening in that space with very forward-thinking regulators that allows us to find what is the actual certification process for aircraft. You cannot apply the same certification process as you apply for a commercial airliner. Flying cars will be a different thing. But less than 2 kilo drones that can perform a lot of very valuable tasks in society, they can be brought into that space through a lot of demonstration of failure modes and all that through empirical research. Right, so I think that there's a common understanding that the two worlds have to converge somehow, and that that's one of the primary focus that we have. Working with chipset vendors, working with drone manufacturers, working with the platforms that Pulkit mentioned. That platform itself can actually lead to just proving that, hey, you don't need to be at 10 to the minus 9. If you are at 10 to the minus 6 on these parameters, you can fulfill that. And that platform then can be adopted by multiple manufacturers and use that truly as a platform to develop further business, Pulkit mentions around data, around exploitation of data and fulfilling those key tasks that actually will all benefit from. So it's a very complex picture, but it's just starting to gel together quite well. That's my impression.
And do you see the industry and regulators agreeing more on a complete segregation from manned aviation, or some kind of merged or fused airspace?
I think that it's going to be a harmonious, orchestrated combination of multiple different ways of doing that. I mean, can you say that autonomous driving today is seen as everybody sharing the same lanes, but now there's starting to be very active voices about lane segregation for autonomous driving, because you can make both worlds, safer that way. I think in some cases there will be airspace segregation, in some cases there will be total coexistence, right? And it depends as well on the category and the performance of the drones themselves. Some of them will be able to enter control airspace, some not. There will be a whole spectrum of possibilities for that. I don't think there's so my point is that there will not be one answer to that question. It will depend very much on the type of drone, the specific locality where this is going to happen, and the mission itself.
Right. And as enabling technologies for this kind of airspace fusion, I mean, they haven't been sorted out yet. There's the option of transponder, miniaturized transponders, or 5G. There's the option. I mean, there's the problem of self-reporting of some key flight data, like altitude, for example, that as of today, pretty much nobody's doing. How are you? I mean, what kind of tests are you running to address that?
So, like I said, there are a lot of
And if you, for example, are solving the problem or addressing that, what are you doing?
I'll let Pokey go first.
Well, where do I begin? I mean, this.
Are you reporting altitude, for example, in your drone flights?
Unfortunately, we're still depending on the pressure sensor because for customers we work with, the vertical accuracy is not as important as horizontal accuracy. So we're still relying on the current industry state of the art.
Right.
I would say there are other companies that are improving the efficiency, but the solutions might not be exactly cost effective at this time. So I would say on improving the hardware capabilities, we're primarily just focusing on one key piece, which is a huge barrier to entry in our industry, which is precision landing. We're continuously improving the efficiency of that. Aside from that, we're building systems that allow the drones to pretty much have a very low downtime, as little as less than 5 minutes after each mission, allowing for immediate after 5 minutes immediate takeoff and continuation of the mission. Aside from that, I would say our greatest metric, and Daniel pointed it out as well, is how many flights have you flown, reliably landed the drone, taken off in 20 to 30 minutes without any issues. If that number is in the thousands and the error rates were less than 0.1%, I think you're doing decently well. Okay. And the industry, the customers, they are very open. They understand that it's like the early days of the self-driving car space. They want to get in on it. They understand that initially things might not exactly be perfect, so they're very willing to work with us and move things forward as well.
Excellent. I think we run out of time, but it's a huge topic, and we just scratched the surface of that. Thank you. Thank you, guys.
Thank you.
Thank you.
Thank you.